Hello.
Hi,
Hey,
Guhan.
Yeah, sorry, I have some problem with the computer. Yeah, just join.
Started the recording, Shrikant. Please feel free to start whenever.
Okay, so just thank you everyone for joining again. So just a bit of a small recap to go over some of the corrections we made since the last meeting. So one correction we made is to the reference architecture. Suresh, do you want to kind of just walk through this portion?
Yeah, so this one, as we discussed, thanks, Shrikant. So we kind of removed the extra hub, VOQ syncd scripts. We looked at and all the different call flows can be done via without going the VOQ sync scripts. What we thought, so we directly, so conceptually you can think the Arc agent can operate the VOQ system DB, which happen to be residing on the control card or supervisor card. So that's the what we discussed from the last meeting.
Okay, so basically Arc agent is subscribing to those tables directly, right?
Yeah.
Okay.
Yeah. So I think one other point that Guan made, this is is that we could organize the so-called chassis DB instance into multiple DBs. One of them being the VOQ system DB and potentially others to carry other states. So I think what I can do is I can try to capture that in a revision of the HLD that I posted. So just to capture that in one more level of detail, and so it lines up with what's being described here as well.
Okay. So effectively additional things that may be chassis wide needed.
Yeah, exactly.
Okay, perfect.
Yeah.
So
that's it.
Any other comments on the picture? Sorry. Okay. So the other change we made is to change the text around the automatic determination of switch ID, right? Is that so we specifically say now that this can be done by a configuration attribute and mention that the automatic assignment is optional. The configuration elements requirement section, again, we mentioned that the switch ID for each ASIC is a configuration attribute. This is the addition there. So to the extent we reviewed the document last time, these are the changes, at least we capture from the comments portion of that. So now we are ready to start reviewing the document where we last left it, which is, I think, beginning of section 2. So is everybody ready to go into the new section? Any comments so far on what was previously reviewed? Okay, so this is so let's start going into configuration, a little more of a detailed design into this, right? So here we talk about configuration flows for system port creation and how the configuration itself is handled, right? So we show two different options here. One is where the configuration is centrally processed, right? And then it is pulled on by each VOQDB. This is the model we are going with. So this shows the config processing on the supervisor card, right? You have a config gen processing the system port configuration, populates the config DB, and then we envisage something called the system port config manager that reads the config DB and populates the table in the VOQDB. I think this would be the system port table in the VOQDB. In a sense, the system port VOQDB is a little bit like the app-DB for that particular table. Suresh, do you want to add any more commentary to this specific portion here?
No, I think, yeah, until there's no question.
All right. So the other option we thought of earlier was that this could also be locally processed on the ASIC level itself. This config could be processed at the ASIC level, but that was removed, just showing only the processing at the central. So we're going to look at the config DB schemas itself for the config DB, what we would put in for the new configuration attributes. So in the device metadata section, we would be having switch ID, which each ASIC needs to have its own unique switch ID in the system. Switch type, this is to differentiate fabric and NPU types from earlier discussion. And the connection parameters for the VOQDB, this is an IP and a port.
So one clarification here that may be of interest is this config DB again needs to live in the chassis instance, right?
So
because it has to be visible to. Well, I guess that is another point of discussion because.
So it could be right. It could be coordinated from there to generate this information. But I guess since the ASIC needs these parameters to connect to the chassis instance, this was shown in the ASIC level configuration.
Sorry, I wasn't precise enough. Let me be clear. So yes, I get why the device metadata needs to be in the config DB and it needs to be in the FSI config DB. This is what our document also refers to. I was actually kind of looking a little ahead at the system port table.
Okay. Yeah. Got it. Thanks.
So that's the one that
Yeah.
So the next one, the system port table. Yes, this is at a chassis level, right? This is
for. Excuse me. So sorry for clarity. Does it make sense to separate out the config DB of the line card SONiC from the supervisor or a control card SONiC? Because they have different content and different tables, right?
So we could, in this section 2.2.2, I could add a note saying that this is in the supervisor, if that helps. I mean, unless you're suggesting a different way of organizing this.
Yeah, I mean, I was just thinking like maybe separate out all the tables that are needed in the control card versus what's needed in the line card instance into. I mean, yeah, you could multiple ways of organizing this. I don't know what would be clearer. I mean, maybe others have different opinions on this.
So I guess without changing the organization of the document, I could add notes here to say this is in the supervisor. Once that's done, we could probably come back, take a look at it and see if you want to restructure or reorganize.
Yeah, that'll work. Like I think even the device metadata, right? For example, it's only the line card.
That's right.
So we could like add a tag for each of them saying like where they belong.
Okay, so we'll do that.
Device metadata, we did consider one more option that we can call this as a system device metadata and populate it on the I mean, but this since it's a config, we were thinking that that won't work. So that's the reason this is we kind of left it as a line card.
I mean, there has to be some bootstrap configuration that tells the line card instance that it needs to connect to a chassis instance, and this is what is that bootstrap information.
Correct, exactly. Yeah. So that's
this looks right. All I'm saying is just for clarity, like just tag each section into like this goes here versus this goes here, right? That's all I'm saying.
Yeah, we'll do that. So the next one is the system. Go ahead.
Sorry, I had a question. So there are two config flows, one from the supervisor and one locally on the line card?
Right. So I guess on the supervisor, the config DB is processed where it processes all the complete system port list and puts them in the VOQ system database where it will be pulled down by all the ASIC from the ASICs. In addition, the ASIC has its config DB, which is the standard stuff that it always had, in which there are a few extra parameters, as this one shows. So, I mean, the way this ASIC connects and pulls information from the VOQ system database is more like pulling it from the app DB as opposed to pulling it from the config DB, if you want to draw a parallel, right?
Okay. So that means when like org agent on the line card initializes, it will get the local ports from its local config DB and the system port from the chassis config DB. And then
I guess, right, from the VOQ DB, I guess the chassis config DB might mean a config DB. I guess it's, if I go back to the picture, that might help, right? So I think if you connect here, when the ARC agent pulls it down from the VOQ system DB, we are saying this is not a config DB, but it is more, this system port config manager has taken it from a chassis config DB and put it in this VOQ system DB, right? Which is more like an app DB kind of a thing as opposed to a config DB.
Yeah, so what you're saying is right. So basically, when system on a line card ARC agent boots it, it will load local information or existing SONiC architecture, like a fixed configuration boxes. It will load the app DB as currently. Along with that, ARC agent enhanced to load information from the VOQ system DB, which is a global DB. Today we are thinking that it's only system ports majority to start with, the system port creation time.
Okay, so another dumb question. Since the system ports are pretty static, why can't we have it locally on the line card as well?
So that was gonna be our other option that we kind of removed in this version of the document, was that, yes, you could technically have all the system port configuration made available as part of your config db.json to the ASIC. It could be processed there as well, right? So that was the other option, but we removed it just so that we don't keep discussing multiple options. Yes.
Right. So I'm just curious, like, is there any
so I mean, it would be, there is no drawback, and actually if the long-term goal is to go towards a dynamic model, that might actually be the way you would do it, right? Is that everyone has the, right now everybody would have all the list, but in the future you would have a shorter list.
Only thing what we are thinking is that we modeled initially before this, I mean this week, previous week when we presented, we thought that the VOQ system DB can be like a state DB, but here we are modeled as app DB. So when you load it on every line card, then the app DB will have a same content, will be populated by, I mean, we are thinking that is the system ports is a static configuration. So it has to have all the system ports configured or provisioned at the time of boot up. So it means that if every line card loads it, it's going to be a overlapping information, because with the current SOI expectation that all of them has to be given at one time. But when we go dynamic, sure, that what you are proposing, thinking is the right choice. But we kind of removed the dynamic nature of logic from this document to keep it with the static provisioning logic.
Even with static, each line card is pulling the same copy of system ports anyway, right? It's just that we are not putting it in config db.json. Instead, it is pulling it from a database. So I was just wondering, like, would it be simpler if we just put it in the JSON file and then the code flow remains the same?
It could be. So if I go to that flow, right, let me go to that picture where we process this, right? So this one we said is happening on the control card, right? Config gen processing system port table, putting it in config db, right? So what you're saying is this, why could this not happen in each ASIC by itself if your config db.json has the complete list? All right.
Right.
So that was the option we kind of removed when we went to this version of the document, because we wanted to show everything coming from the central supervisor card. If there is a desire in this group that what you're mentioning is preferred for system ports, at least, we could put that back and describe, maybe with some changes, and describe it.
So I think the way we had thought about it was, right, like I think in prior discussions was, you kind of have a boundary. It's more an architectural consideration, right? You have a boundary between global information which lives in the control card, or the so-called what we had called chassis DB, and you have DB instance, and you have all the local information that lives on the line card instance. And so that's so in that, if you from that point of view, it's consistent with that view of the world where you say you have a global store of all the kind of chassis wide information, both configuration and state, and then anytime you're operating on a device where that state is of interest, like in a VOQ chassis, then you would be told to connect to that instance and access that information. That's kind of the main. That is how we approached.
I think, yeah, I think I agree with that view. It's just that I thought about this. I think, okay, in the long term, right? So, let's say we want to deal with those dynamic things, then probably it's better to have the in the local config DB only have your own system port, and we use the chassis DB as a aggregator. So each local database also they put those information into the chassis DB and then synchronize across the system, so that when we add a new line card or those things, then those new system port can be synchronized across the system. Yeah, I think that should be the eventual goal where we reach here. So for this one, for the current one, it looks like we don't have that kind of a dynamic capability, right? So we always, when we start the org agent, we'll get the full system port and do the initialization. After that, we will not learn a new system port, right? So that's his current my understanding. So in that case, I feel like that means that when we start our local org agent, the chassis config DB must be populated first, right? So I think that could create some external dependencies when we start initialize our local line card.
Right. So currently it creates a bit of a latency, possibly on issuing a switch create, because you need to connect to the supervisor and pull it down. So I mean, it might make switch create faster if you have it local.
It's not I'm not that worried about the latency. I'm worried about let's say at that time the supervised card is not populated. Sorry, the supervised chassis DB is not populated.
Right. So
someone didn't run this config gene on the supervisor card, and populate all the system port in there. Then we may have create a dependency there. So I think what. That could cause some troubleshooting because I think other information in the chassis DB are all dynamic, right? So then the local line card will dynamic put those information in the chassis DB, and other get those information and synchronize those other states like port channel or neighbor. Those are all dynamic. This system is not that dynamic, so there might be some dependency there, causing us, troubleshooting those would be a little bit difficult.
So Guan, is there a preference then that we could just put it locally? I mean, it's definitely reasonable to do it. That you start with the complete system port list locally available, and when we go to the dynamic, it will be a shorter list.
Yeah, that would be my.
I was concerned about one other debugging scenario, which is that, imagine somehow two different line cards are seeded with the wrong set of sysports. That'll be painful to debug in some sense, right? Like we could, if the system port list is in one place, and if the line card has to connect to it and get it before it starts, then isn't that more guaranteed that we will have in sync across all the line cards in the chassis?
Yeah, I think.
But initially you would have the complete list available, right? I mean, at this point, every ASIC will have the complete list of system port table available.
That is correct. I mean, I agree, right? Like it's a very subtle difference. Maybe we could go either way, but I'm just thinking about the scenario where imagine we are expecting the system port to be populated for all ASICs through some external mechanism, right? Through the mini graph or some other mechanism. And that, like, what if something is wrong and then we end up with slightly different lists between two different ASICs? That will be a very painful problem to debug, right?
Yeah, but in that way, the configuration per se, I mean, it is a case for a majority of config problem, right? Like even the peer config, if you don't configure correctly, the IBGP peer, it can go wrong, right? So
IBGP peer not coming up is different from you having two different ASICs having completely different views of what system ports there are, right? It's like this, with this architecture, it becomes painful to debug is what I was worried about.
Yeah,
I had one question. So, like, do we know? Do we on the supervisor card? We don't need system port information at all, like to program.
All, yeah, we don't. Yeah, we don't need it at all.
For fabric programming, we don't need anything. Like
that's
no. This is only just say that one config operation. Like if you do it per line card or per ASIC perspective, you need to load it on every ASIC. So it's just the assumption that the operational model that every ASIC should load the system port, but here you just load it on the control card or supervisor card, and that's about it. Then any line card plugged in, there is no further loading of config. I mean, that kind of minor benefits there with this approach of a control card and a supervisor card holding this information. Beyond that, I mean, if you look at purely from a static configuration perspective, yeah, it makes sense to do it in ASIC, but our preference also go with control card to load the config, which is system-wide config. Though it is not applied on the control card, it is still a system-wide config. I mean, if there is no objection, I think this is better, but
So is there a strong desire then that we want to change what's described here, or should we just leave it as is? I mean, we could easily go one way or another. I mean,
from our point of view, Arista's point of view, we see no reason to change what's being proposed. But yeah.
So, Subshek, go on. Any last thoughts?
Sure. Well, what is this system port config manager?
This is just reading the config DB entries for the system ports and putting them in the VOQ system DB. Right?
Yeah, it's just a reading. Yeah, I mean, we thought in SONiC. I mean, you understand SONiC as like there is a config manager.
This is system port config manager is leaving the
supervisor.
Supervisor.
I mean, this part, honestly, I think. Again, like there are two options here. I could imagine a system where the VOQDB is another Redis instance, right? The VOQDB is inside a different Redis instance. There could be a different config gen that directly writes to it. Yeah. Like, there is a config DB inside that Redis instance.
Okay. I mean, we thought the config gen could directly write it, but we thought we model VOQDB as like more like app DB in terms of schema and everything. So we thought like, but it's a minor.
Yeah, I mean, I think it helps to, maybe we should just name a config DB, app DB, all these things inside the VOQ chassis or the Redis instance. I mean, we have to differentiate the Redis instance from the DB itself, right? So you see what I mean?
Yeah. Mm-hmm.
So that must be like a config DB inside the VOQ Redis instance and app DB inside it and so on. So if we do that, maybe it becomes clearer.
Yeah, I see. Okay, yeah. I mean, that could be done. Yeah, I mean,
so then you will essentially have two different config gens, right? One config gen writes to the config DB of the existing SONiC Redis instance. The other config gen would write to the new Redis instance.
Yes, yeah. These are new. Yeah, these are new ones. Yeah.
Yeah, this is exactly what I meant when I said I'll amend my earlier document with this exact level of detail. So it should be consistent with what you just mentioned.
Okay.
Also, one more comment. If we want to have all the system port configurations on the in the chassis DB, like on the supervisor card, are we making an assumption that all the attributes of system ports would need to be known to all the instances, or would it be, because if this is sent to each individual FSI individually, then there will be more control on which attributes need to be published to remote LCs or remote FSIs, rather than every config of that system port going to every to every chassis instance, up to every SONiC instance. I mean, I understand it may not be a requirement today, but if you think down the line where there might be local attributes, then having the config process locally might scale back.
So the way the VOQ spec kind of handled this from a SI level was that anything that was local was generally handled in the existing port tables themselves, which are kind of local. And the system ports only handled things that had to be globally known. I think that was one of the things that went into what was in the table, right? That because they are significant forwarding wise. I mean, I don't know if SI will relax that in the future and add more locally significant only things to the system port table, because they definitely have a place where they can currently put them in the port table, right? If those things do come up.
No, so I agree with that point, but I think what the way I interpret the statement from SI is anything that is required at SI level from a system port standpoint will have to be known everywhere. That doesn't necessarily mean that those are the only attributes that the system port has.
Okay.
And just a minor point, I don't think there are other ways to solve it, but it's.
I mean, yeah. So far, everything that's that has to be published here has to be known to everybody. Like there is nothing like as that's the case so far.
I agree. Yeah, so far that's the case, but just want to see if that's something we want to take into consideration before choosing the two options or one among the two options.
Yeah, the system port properties. If you think, are you saying that each SONiC instance will have its own property compared to the global? I mean, here we are talking about whichever specific is what system port will be common. The rest of things can be inside, but we don't need to worry about as a config because those are very specific to that particular instance, right? For example, even BGP peers or any configuration or lag, a lag is another example. It's very specific to that particular SONiC instance.
And I think if you are making an architectural statement that every attribute of a system port has to be known everywhere consistently, then it doesn't matter. I think if you make that as an architectural guideline, then we are saying that it doesn't matter whether you configure that in the supervisor DB and then have everyone sync through it, or you have to configure independently. But I'm assuming that if we say we want to configure this in the supervisor DB, that's an architectural statement we are making, right?
I think that is the intent.
That's the intent.
Yeah, when the system port was first created, it was created only to capture things that were needed everywhere, right?
Perfect. Yeah.
So I think we'll generally stay with that intent overall.
Sounds fine to me as well.
So we ready to kind of move on? I mean, I'll make a change if somebody requests that we want to have the other option, but I'm inclined to leave it the way it is right now.
So, Srikanth, sorry, just to summarize, there are two different questions we discussed, right? One was, should we move the system port table to each ASIC? The second thing was to the specific thing here about, do we need the system port config manager to copy from config DB to VOQ DB?
Right. I think, yeah, to the second question, it was done to maintain the existing parallel that config and app DB are different. And then ArcAgent generally works on what looks like an app DB, right? It doesn't. So that's the intent, because the VOQ DB will also have dynamic neighbor entries, which are more like app DB entries, right?
So in our view, we are looking chassis DB or the VOQ DB as more like app DB, extension of app DB, but happen to be in the control card or supervisor card, right? So that's our view of it. So that app DB is populated by across line cards.
Yeah, I think it keeps it cleaner to have it separate from the config DB there.
So does this mean that the supervisor card has to be up and fully ready, before we start any line card?
So yes, if you put the table, if you put the configuration only on the supervisor card.
Yeah. I mean, some extent it's true. To chassis to work, we need a card to be up some extent because there is some peripheral management and everything, right? Like there is some sort of things to see that. But if you look at from a VOQ, if you ask, probably not. I mean, we could bootstrap it almost parallelly, but this configuration is coming from control card means that that's where the latency, what Srikanth was saying. But
so it definitely does make it more asynchronous, and things can come up probably faster if you kept it local, right? So I mean, there is that to consider. I mean, switch create does take quite a bit of time today in most switches. The sooner we can start it, it would be better. Instead of waiting for connection to the supervisor to pull all the information on this. I mean, that's definitely there.
The supervisor has to be up in a way, some extent, because this SFM switch fabric has to be initialized. Even the communication across the line cards or the ASIC instances to happen. So, so that is there.
I mean, so I don't think it's practical to assume that the supervisor can like be impartial, because it has to be fully functional and have in stable operation, even to like power on the line card.
Yeah,
and so and
the
set
other
up
thing
like
is
low-level platform management, network connectivity, and so on. So it doesn't feel like that is an area that is worth optimizing. I think to me it feels perfectly reasonable to assume that by the time the line card is actually ready to get to this stage where it's processing its config, that the supervisor is functional and that a connection to the supervisor instance is already in existence.
But given that your path to the management,
need some kind of explicit change of information, like supervisor card says I'm ready, and then the line card will wait for that signal before fully starting?
So I do not know if we need an explicit. What we have is at least what we're trying to implement is a switch create blocks on waiting for that information to come down, right? So we do not issue the switch create until we have the information from the system ports, right? So that we are done. I do not know if you need an explicit indication though, because
you don't see a need for explicit to say that system. I mean the control card is completely up and running kind of logic. Rather, we have a signal to today when all the system ports, like if there is 1,000 system ports, we will tell that 1,000 system ports is sent over the DB to end of the config or something like that, to tell that every SONiC instance to know that it can go ahead instead of waiting for.
But how do you know that whatever in the chassis DB is complete, like it has all the system ports?
So we kind of using right now, if you look at the implementation aspect of it, we kind of using the number to know that, okay, there is number of system ports is 1,000, and we kind of put that in the DB and as a kind of indication to each because this is a config, right? So we need to tell the end of config. Hey, this is all the config is. So the Arc agent can go and create it. It's kind of synchronization. It is not to say that the control card is up and running. It's just to say that the config is, this is all the config is.
So just wondering about this thing, this handshake from RP, I mean the supervisor card to the line card. Won't the platform infra management will take care of it? Meaning even before the switch DBs come into play? Because there could be other intricacies in the system, and the platform infra would want to ensure that both are in communication with each other.
That's certainly been our assumption.
Yeah, I mean it is assumption, but rather than there is no explicit message exchanged in the via DBs, right, or via Redis.
Yeah, I mean a system is ready may mean different things to different modules, right? I mean we don't want to make one single thing the thing saying that the database is ready. It may just mean that the card is booted up and doing a few things.
Let's say if we reboot the supervisor card, I guess all the line card will also be I don't remember. Will all the line card be for example, let's say we reboot the supervisor card and meanwhile we're putting those line card. And when the line card comes up, if the supervisor card hasn't been fully up yet, then what would be the line card do? Because in that case, if you're trying to learn the chassis DB, there's
so Gohan, the line card would it would be unlikely that the line card would even power on properly until the supervisor came back up and was functioning, because it has to go through a platform init sequence well before. So, and the way that would be ensured is that the Linux init sequence would not need to be coordinated so that the low-level platform init takes place, and then it triggers the network connectivity to come up, internal network connectivity to come up, and then all these database services start up, and then the line card connects. That's how that would be the kind of.
But it depends. Sorry, it depends on which state the line card is. If the line card is already up and it's pulling data from the VOQDB, and then the management card like reboots, then the platform init won't help in that case, right?
No, the line card is not line card is pulling the chassis DB lives on the supervisor, so there's no way it can pull data from. So if you just walk through the sequence again, imagine you have a running system, right? And for some reason the supervisor is rebooted, right? The first thing that would happen is that the line card instance would lose connection to the let's call it the VOQDB or the chassis DB instance on which the VOQDB lives. And once that happens, then that point it loses access. There are some choices you can make as to how to deal with that. But more importantly, I'll set that aside for a second. But once the supervisor reboots, it's going to go through its init sequence. It will have to power cycle the line card at that point. So whatever the line card does in between the point where it first loses connectivity to the supervisor and then eventually gets power cycled when the supervisor comes up is kind of immaterial, actually.
Now, even if it is not, line card is not restarted, when supervisor reboots, when the ARC agents pulls this system port information from the VOQDB or chassis DB, there could be a chance that the information is changed. If there is information changed, then you need to restart the line card, right? Because it's not the platform dependency, because the way today's site defined, system port has to be a switch creation. If any discrepancy happened, then we will end up rebooting each and every SONiC instances of it, like the FSIs of it. So it is not guaranteed that we can make it work if there is no problem in changing. Any content is changed in the system port list. But if there is a change, we need to restart the FSI or the SONiC instances of it, each and every line card SONiC instance of it.
Right. So the platform may not force a reboot, but your reason to reboot might be if your config changed. But there could definitely be a checkpoint to say nothing changed and not reboot the line card. That's
no, but actually it's a fair assumption what Karthik is saying, that also assume that, it's a fair assumption that, the control card should be up and running, because there could be some dependencies that we need to restart the line card. We cannot guarantee that, but I'm saying even in any case, it doesn't, it makes sense to consistent check right after any reboot, right? Particularly control card. When control card reboots, there should be a consistent checking to make sure that whether line card can continue to operate or has to be restarted, because their SFMs has to be reinitialized and a lot of other sequence has to be reinitialized.
Yeah, I think.
One question.
Sorry.
Go ahead.
I think it's like just we talk about it, right? So it seems there's some dependencies we need to solve, and I was just thinking, initially if we can just simplify the problem, maybe it's easier for us to deal with. Because I think for us as the mini graph, I think it's pretty much. When we make that available to the whole system, I think it's pretty much consistent, right? So each line card just need to pull the latest mini graph, and then using the config gene to generate the system port DB information. We'll have all the system port DB information, and then we just don't have these dependencies. right, on the chassis DB anymore.
Right, so you're suggesting that if it's in the if the minigraph or the ASIC has it, then effectively you got it, and if that changed, it will be told anyway if something reboots.
Right. Think about it. I think the mini graph for the chassis system is pretty much static, right? So if we're not adding new line card or removing new line card, when the system is there, we have our management system have prepared the mini graph in advance, right? So long time ago, and then every line card just pulled that mini graph. I understand there was some concerns about whether that information is consistent across the chassis or not, but I think just to simplify the problem, right? So I think we can guarantee that information will be consistent across all the line card. I mean, it's yeah. So then each line card just run the config gene to put the system DB information in the in each config DB, and then we don't have this problem, right? So I'm not saying that this is a end goal for us, right? So because it doesn't handle those dynamic part well, but it seems to me that it's if we can make assumption that those information are consistent across a different line card, it just seems simpler for us. When we restart the line card, it has all the information it needs to get initialized. We don't have to wait for anything else, right? So we don't have to wait for supervisor. It just once the supervisor is ready, initialize all those links, start these links, and then once the packet gets flowing through the supervisor card, then the BGP session will set up, everything will be working, right? So I'm just thinking, if we can make the assumption for this particular scenario, and to start with, maybe it's just simpler for us to deal with.
Okay, so in that case, the system port information, it's a config DB, and doesn't need to be. It can be just in the config DB, right? It doesn't need to go to the chassis DB at all because it's a config per line card at this point.
Yeah.
Okay.
Yeah, and then in that world, there's no config DB in the chassis, and it's only like state that one line card needs to export to the rest of the world on a live.
Okay, so then VOQDB will only have routing interfaces and neighbors.
Yeah.
Right, and the lag information, those dynamic information, we can populate and deal with it dynamically.
So let's make another equivalent of this picture with just assuming it's all on the line card with the ASIC. Maybe the system port config manager will just become the port manager at that point, right? The port config manager.
It was my bad that I just removed that picture just 5 minutes before the meeting. Probably that's not we are going to go.
Okay. All right, so we'll add that and probably edit it and to reflect any discussion we had. Okay. So I think so I guess we can consider that discussion closed now that we're going to add that back, right?
Yeah, I will put it back, Shrikant. Yeah.
Okay. So the config DB. So this is a system port config table, as I think Ishwaran pointed out earlier. I'll make a note that. Okay, now this changed, right? This is just config DB.
Yeah.
Okay. Right. Okay, that makes my job easier. Thank you. And the config DB schemas, we have the switch ID, which is a number between 0 and 1023 base. I think it's aligning with what size is for that. And the system port table as well in there. Okay, so let's see how much of this document changes based on what we just agreed to. I have a feeling a few more places will be different.
Yeah, let's quickly go over that VOQDB, right? In that case, probably the system data will not be in the VOQDB. It is basically config. System port will also a config, so both will be gone, correct? So that's that's what
they will be gone. I guess they become they show up in the AppDB locally then, right? Just
yeah, it's a local AppDB config. Yeah.
So instead of VOQDB, this system data and the system port table will move into the AppDB.
The config DB for local config DB, right?
Yeah, local config DB from there AppDB, right? To ArcAgent get it.
And I wanted to ask that question. So there's going to be no transformation between what's in the config DB and what's going to go in the AppDB? While I realize that there's an architectural pattern here, I think the question to ask is
yeah, that is
that transformation is redundant, I think.
Yeah. So
I don't know. Guhan, do you have any thoughts?
Should I mean, today ArcAgent doesn't read from config DB directly. I mean, are we saying ArcAgent can directly read from config DB, or the config gen can directly write to AppDB? That doesn't happen either today.
Let me think. Okay, so currently I think if we want to reuse the code, then basically the port arc will read those from AppDB.
Yes.
Right. So for the system port, yeah. So then someone need to copy that from the config DB to the AppDB. I guess there's a reason why we did this for the for those local ports. But for this remote system port, let me think.
So based on some choices we make later, that might differ. Meaning there are some options down below that will require some more work to be done to create kernel devices and things like that. In that case, the existing scheme will work fine, where from config DB something in the sysport manager or something can copy it into the AppDB. Maybe we can look at that, and then based on those choices we might come back to this.
Yeah, I think if there's a reason need to do the copy, I think basically I don't expect the schema changes, right? So you just copy those things in the config DB to the AppDB, to the local AppDB. Sorry.
That's right. Yeah, that's right. Yeah, and eventually this also will be gone. Like maybe like whenever that when we have a dynamic laning, right? Dynamic laning of system ports.
Right.
You would still have it for the local ports. Right?
Yeah, local ports will be there, but this kind of copying, the config will be have only local ports. The system ports per se is probably. Yeah. I mean, it's nicer if ArcAgent can directly read it from a config DB if you're inclined to it, so that nothing changes. Just read from a config. It doesn't have the code doesn't exist today, but maybe we can add it. Our config gen can directly write to application DB. These are the choice. So we remove the system port config manager. Or is there any? I mean, we don't really have any reason other than that for today. We use it that in a control card just to copy from a config DB to application DB. Nothing more, and it doesn't even come to picture until there's a config change.
So I think if the longer term goal is that we want it to be dynamic, I mean, putting it in the AppDB is the right thing, right? Whether config gen writes it directly or not, because when you get it from a remote system dynamically, it's likely to go in the app.
Even in that case, it's VOQDB only, right? Not AppDB.
Okay. So it's okay. That doesn't matter then.
Doesn't matter, yeah.
I mean, so do we want to hold this call and kind of come back to it later, as Karthik suggested, or are we ready to make a call on this?
I think we can. Is there later slide to talk about how to initialize those system port, or?
Yes, yeah, that is a call flow sequence, yeah.
Okay. Yeah, then we can.
What is your thought, Guhan? Just to get some idea, what is your thought?
No, I mean, I think eventually those system port is better coming from the AppDB one. So once we have these synchronizations, imagine, each one is putting, getting those local system port into the global chassis DB, and everyone else reading from the global chassis DB. And in that case, it would be the AppDB would be more appropriate for them to read from, right? So I think probably, we can do a system port manager at locally, which currently job is to copy the local config DB into the AppDB, and later, that manager should reading from the local system port and put into the global chassis DB, right? So that kind of synchronization that manager can do.
Okay, yeah, and that's in line with what we are also thinking. Maybe Ishwar and Karthik, is that also works for you guys?
Sorry, I had a question. So since we need to know the complete system port list at switch create, so if we put it in the AppDB, then Orc agent has to stop till all this information is copied.
That's right. So agent cannot start without getting all the system port information. They
right.
will be
So then we are like moving the orchestration in the line card right now, right? So wouldn't it be easier if we directly read it from the config DB? Because in the dynamic case, when we support that, then the restriction on SI has to go that all the system ports have to be populated at init, right? That restriction has to go away for us to support dynamic system ports. Is my understanding correct?
Yeah, yes, that's right. Yeah.
Yeah, so if that's the case, then if it's a static, then and we need all the system ports at like switch create, then wouldn't it be easier just copying it from the config DB? I mean, taking it from the config DB. And once we design for dynamic ports with a different side, then I agree we need it in the AppDB.
That's what we are saying. So anyway, we are going to go AppDB. What Guhan is saying, then it's better to have a Arc agent to read from AppDB, and let's write this extra system port config manager to populate it for now. And probably
right. No, what I'm saying is like if the system config manager has to copy from config DB to AppDB, then Orc agent has to stop till all this config is copied to AppDB before it can call switch create, right?
Yes.
Yeah, so I'm saying in that case, wouldn't it be easier just because the information is already there in the config DB? So we just get the information from the config DB and then do the switch create.
So you want to avoid the extra stalling.
Yeah.
And then what you're also saying is that longer run when it is dynamic, there's no stalling anyway. So
exactly.
Effectively, you would not need to add stalling code that you would remove later.
And that is the case even for us local ports, right? If you look at that way, then we can. I mean, a lot of config is like that. I mean, local ports even today exist, and there's a port config manager who reads the config and pushes
right,
to that.
But we don't have
not
to
a switch
specify
create blocker, right?
Exactly. We don't have to set a list of local ports when we do the switch create, right? Each port can be created later.
I see. Okay. I mean, yeah, that's true. I mean, but yeah, it's
Yeah. I think this systems make the code simpler. Yeah.
Okay.
I think so if we can directly read from the config DB, seems to make this code simpler, right? So the config DB, when the Orc agent when they start the config DB, I will have complete system port information, and then it just read from there. Just read from config DB and create those ports at the switch creation time. Yeah, it seems similar. Yeah, I think.
Okay. All right, so that's good. So I think it'll change some call flows that we described below, but it makes things simpler definitely. Okay, so we are on 12:59. I noticed that Anshu booked the meeting only for 1 hour, even though the original SI call was 2 hours. Are we going to stop on the hour, or are we going to go for the full extra hour?
We plan for 2 hours, so we are.
Okay. Yeah. So I was hoping we could go for the full 2 hours, but I wasn't sure because
Yeah, let's go. I mean, we are okay. We can.
Yeah, if everyone is available, let's continue. I'll just extend the invite.
Okay, perfect. Okay, so the system port interface table is the next. So I think based on what we said, these two become config.db, right? Local config.db entries. So we don't need the app.db entries for that. The VOQ
One
neighbor.
question. Do we need any schema for fabric ports, or there's nothing to be configured regarding fabric on control card?
So there is no configuration for it. It's a discovery, right? So we haven't described the schema for fabric ports here, right? I mean, they are in the port table, at least from a SI point of view, right? The same port table as the existing ones.
Yes.
So there's no, so they do not need any configuration, but they are discovered and monitored for stats.
So
Okay,
that, I mean, that doesn't. I mean, that is not related to the chassis DB or VOQ DB. That is will be as like a more like a ASIC DB. Like you discover the ports, and it is going to be a single. I mean, there is no synchronization on them, right? It's going to operate.
I remember the site has a fabric port object.
Correct.
So
Yes.
I thought Psi has it, but it's not a separate object like system port object. It is in the same object type as the ports.
Oh yeah, as the ports, then.
I mean, the equivalent of port config INI will drive creation of the fabric ports, and it should not need. I mean, again, like there's nothing to configure on them, right? It's just there.
Just discovery. Yeah.
So the regular port schema should be okay for fabric port, or do we have to update that one?
No, regular should be okay.
Okay.
Except
I mean, there must be like a type or something that indicates it, right? Other than that, it should be okay.
So I thought initially we said it will be discovered, or it will be configured by the org agent of control card.
No, it's all discovery.
I mean, we didn't think a lot on that. Let's put that way, rather than because we want to solve the line cards first before getting into the fabric switch creation and the orchestration port. So that's the reason this document primarily focuses on the assuming that the fabric cards are orchestrated as it is, and we're just trying to create the chassis orchestration, right? So we will get. I mean, we have a section, but we didn't even think a lot on that yet.
It's very light on content for fabric ports, I mean, I admit.
Sure, okay.
Yeah, I mean, there is a fabric, I mean, we are sketching out a document to describe how fabric is going to work. But I think the idea is that we need it in the SOC properties essentially when the SI calls, when the create switch is called, and we don't have to create these ports explicitly. We will create the SI objects at some point. I mean, SI will create them so we can get them and use them for monitoring and things like that, but it doesn't have to be, we don't have to add any new schema for it. We'll probably add a new fabric port table to in the state DB and so on to deal with it. But yeah, a document will follow.
Okay, thanks.
So the next one's the VOQ neighbor table, right? It's this is actually the same as the neighbor table now, right? I mean, so in the VOQ system database, you have the VOQ neighbor table. Where you have the neighbor, the NCAP index, and the VRF, with the key being the IP address in the system port. Right.
One question here, the MAC address for the neighbor table, it's not needed, right? Meaning it's not used, plus do we need all this everywhere?
So I guess that ties into the second discussion on the host interface, right? So it depends on how the host, I mean, it's not needed for forwarding operations. Depending on how the host IP stack communicates, you may need it. Or if you're using a different option, you won't. So it ties into that discussion. The data path programming doesn't need it. Though there may be, I don't know if there are any checks in SI implementations which trip up if they know that there is a MAC attribute is not present. I'm not sure, but
we agreed for a dummy MAC address, any MAC address, or ignored MAC address.
Right.
Yeah, I think not
So for
needed.
this, yeah, for this one, we should clarify it's in the chassis AppDB VOQ neighbor table.
That's right. Yeah, this is
Right.
under the section
Yes,
of.
I think so we'll add a note. So this whole section is under this thing called VOQDB, right? Yeah, the assumption is that the VOQDB is global, right?